Okay, this is going to be almost the first. I usually am behind the camera, and well, maybe not actually behind the camera, but I'm somewhere off camera. That's what I'll say. I'll say I'm usually off camera, but today I'll probably be in front of the camera a little bit. We have a rectangular prism, and we have to find the surface area of this thing. Now, some students, when they come upon these types of problems, they don't have a lot of trouble with it. I've got some kids in here right now who very quickly found the surface area. I had others who did not. Now, the purpose of this video is to show another way of solving it so that if you ever have trouble again on this type of problem, then you can do it. Now, what we have here is a rectangular prism. And it's kind of in an odd position. We're used to these things laying flat, and there you go. But with this rectangular prism, it's still going to have the same process. Now, I'm getting people making faces at me. Okay, what's going on that you're looking at this like you don't believe me that this is a rectangular prism? You're just making faces. Okay, you're going to throw me off now. You're going to throw me off. If anybody has any questions, stop me. I'll stop and talk about it. I'm happy to talk about this. That's what they pay me for. Now, when we have this rectangular prism, the way I would approach it is I would make a net for it. And that's what I'm going to do here. I'm going to make a net for this one. And I'm going to start with this part here, and I'm going to count this as my base. I'm going to count that as the bottom. Maybe I should put it that way. That's the bottom. And I know that this is going to be 11 by 10 because those are the dimensions that it gives me, 11 by 10. So I'm going to go ahead and say 11 centimeters this way and 10 centimeters that way. So it's 11 by 10 that way. Now, I'm going to go ahead and I'm going to do the back. You can't see the back, but it's going to be congruent with the front here. The back will be congruent to the front, and the bottom here is going to be congruent with the top, and then this side will be congruent to that side. So the back, I know it's going to be 4 by 10. 4 by 10. Now, I just realized something as I'm getting ready to draw this. It's not going to be at all to scale because I'm going to run out of space. So what I think I might do is I'm going to erase everything I've done so far. I'm going to make this just a little bit smaller so I can have a little bit more surface area on here to do. So I'll push this a little bit that way. Okay, I'll push it that way. Alright, so once again, this part here, this is going to be the bottom, what I call the bottom, and it's 11 by 10. And once again, this is not drawn to scale whatsoever. And the back that you can't see, that part's going to be 4 by 10. So this is going to be 10 by 4. It just seems strange to me. It just seems strange. Seems strange, and it's not going to be pretty, but because this is a rectangular prism and it's going to have 6 faces and 2 faces are going to be congruent, it'll still work. It's not going to be very pretty, but it will still work. So I can call this 4 by 10. I'm just trying to make sense of this for just a second. 10 by 4. And then this would be 10 by 11 that way. Yeah. Kind of, for a second, that threw me off the way it was positioned. Okay. Alright, so 10. Students, have you learned anything from what I've just done? A moment ago, we had a situation where we worked on a problem and the kids did something that didn't make a lick of sense. And I said to them, always ask yourself, does it make sense? And as I was working on my net, I realized that some of these dimensions did not make sense to me. And so I was able to work it out a different way. If something doesn't make sense to you, stop and try to look at it and evaluate the situation and see if there's something else you need to do. Okay, so I've got the bottom, I've got the back, and I know the top is going to be congruent to the bottom. So that's 10 by 11 here. And I need this part here, which is 4 by 10. That's going to be the front, 4 by 10. And now I need these little side pieces. And these side pieces, when I look at them, they're 4 by 11. They're going to be 4 by 11. Okay, so here will be 4 by 11. And this one is going to be congruent, so it's also 4 by 11. Now, I need to make that 11 just a little bit better. Now, I need to write a numeric expression to represent the surface area of this rectangular prism. Now, I want to stress something, children. You don't have to make a net. If this gets in your way and you're pressed for time, don't worry about the net. But if you've got a lot of time and you want to be precise and a net will help you, then by all means, make the net. Okay? So, what I've done so far has absolutely nothing to do as far as like answering the question. If I walked away right now, this would not get me any credit whatsoever. I have to actually answer the item. So A says write a numeric expression to represent the surface area of the rectangular prism. Now I want to point something out. We got two faces that are congruent in all cases. I mean, we got the top and bottom, we got the sides, and we got the back and the front. And they're congruent. So I'm not going to write 11 times 10 plus 4 times 10 plus 11 times 10 plus 4 times 10 plus 11 times 4 plus 11 times 4. I'm not going to do that. I'm going to kind of simplify it a little bit. I'm just going to, you can kind of phrase it that way. So what I'm going to say here is, since I have two that are 11 times 10, I can write it like that. So that's got this one and this one taken care of. Plus 2 times 11 times 4. And that's got this one and this one taken care of. Plus 2 times, we have 4 times 10. So here I have a numeric expression that represents the surface area of that rectangular prism. Now looking around at my students here, how many of you have a numeric expression that looks like the one that I wrote down? Okay, I'm seeing hands up. Now one of the things I will say is, because of the commutative property of addition, you can have these in different orders, these groupings. And because of the distributive property of multiplication, you might have it 22 times 20 plus 22 times 8. It might be different, and that's okay. But I mean, is it equivalent to this expression? Because you could write this several different ways. Does anybody have it written a different way, yet it's still equivalent?
They do.
Okay, you do, Andrea? Andrea, will you put yours under the document camera and let us see it, please? Now, we do have another screen set up in the back of the classroom, and Andrea's going to put hers on the document camera to show us what she has, and I'll kind of try to read it off. So, what she has is 2 times 4 times 10, which is this cluster, this little grouping here, plus 2 times 4 times 11, which is the equivalent to this grouping here, plus 2 times 10 times 11, which will be equivalent to this grouping here. So it is written a different way, but it'll work. It'll work. Okay? Now all I have to do is just go through and do my computation. Now, and the reason I'm doing that is because now it wants me to find the surface area of the figure. And we got some little Head Start kids outside our window hunting Easter eggs, so I hope all my students are actively listening and looking up in this direction, especially table 6. Especially Logan. Alright, 11 times 10 is 110. 110 times 2, 220. 11 times 44 is 44. 2 times 44 is 88. 4 times 10 is 40. 40 times 2 is 80. So we have 220 plus 88 plus 80. Now, I'm going to combine a little bit of commutative property here. I'm going to do that to see if I can do this easier. 220 plus 80 is 300. 300 plus 88 gives me 388, and now here comes my unit of measure, centimeters squared. So the surface area of the figure is 388 centimeters cubed. Boys and girls, how many of you agree with the answer that I have? Okay, great, great. How many of you who missed it because of this demonstration, you see now where you made your error? Okay, I'm going to look over here then. Tell us, Mason, What was it that you did wrong that now you see you should have done?
What I done wrong is I forgot some of the sides. I forgot 2 of them.
So you left out 2 of the sides?
Yeah.
See, that's the benefit of the net. If you make a net, you're not going to forget anything. And I did check these off, and I checked those off. I did forget to check these off after I got them. But that's why I do the net. I mean, myself, I would do the net. That's just how I do it. But now if you can do this without doing the net, or if the net gets in the way, then do it however you can get the answer correct, okay? Anybody else have realized where you made an error? And I'm really glad we got to see that, Mason. All right, tell us, Merle, what did you do?
I put where the 11 should be, where it's 11 times 10, I put a 10.
So you said 10 by 10? Or did you say 10 by 4?
I just said, the first one I said 2 and then the parentheses, and then I said 10 times 10.
Oh, so here you made a mistake with your computation. Okay, you said 2 and then 10 times 10 because there's 10, and instead of 11, you said 10 times 10. Okay, so that's where you made your error. Okay, one of the ways you might want to fix that is maybe one of the things that you might want to do is look at it and make sure, go back and double check. That could be something you could do. But at least you probably went up with an answer that was close. So that could be a problem. I mean, if you came up with an answer, if you estimate that this is going to have a surface area of a certain thing, like if you estimate it to have a surface area of 400, 10 times 10 is not too far off from 11 times 10. So I can see why your answer probably made sense to you. Okay. Anybody have anything else they want to say about what we've done here? Okay, well that's wonderful. I hope that you all learned something from this. Now, if I were to attach a mathematical practice to this, I used what I know about finding surface area, and then I went through and I did some mental math, and I kind of took advantage of commutative property of addition to solve this. So there's a lot of math practices that can go along with this type of problem. One of the things I will say is that this is actually an example of an easy situation. I mean, we're going to have some problems like this one here, where you have a triangle that's not going to be so easy. So if nothing else, I would absolutely make sure that the easy ones, I've got them down. That way, if you're taking a test and you miss one, I'd much rather at least get the easy ones correct than the hard, and instead of missing them all. I don't know if that's a positive way to look at it or not. All right. I hope this has helped you.